Hi, my name is Andrea Ventola. I'm a PhD student here at the University of Michigan, and today we are running an unconfined compression test. You first want to make sure you wear your safety glasses before you run any of these tests, and I will be referencing the lab manual, and I encourage you to do the same as you are watching. So, a little bit of the equipment needed for this test. You have the unconfined compression device. You have a couple trimming devices for your clay specimens. So this device here trims the diameter of your clay specimen, and this trims the length of your specimen. You have a couple wire saws to help with that trimming. You have a caliper and a ruler to take some initial measurements. And lastly, you have your untrimmed clay specimen. So we'll get started first with trimming the diameter of our clay. So you want to take your clay specimen and sort of place it in the center of this trimming device, and there's some teeth on these bottom plates which you can stick into. Looks good. And basically what will happen is this longitudinal axis of the clay on the device will rotate, and as it rotates you can use your wire saw and trim off the excess portions of the clay. And while it's turning, we want to keep our wire saw sort of touching these edge pieces of the trimming device to help ensure we get an even diameter across our specimen. So I'll begin with just some of the rough cuts. Okay, we'll switch to a bigger saw. And once you get some of these biggest pieces off, it's helpful to have someone else come in and rotate the trimming device, and you can switch to sort of the finer saw. And as it's rotating, you can shave off some of the clay. And you want to continue this until you have a smooth surface all around your clay specimen. So I think that looks pretty good. So now we're done with trimming the diameter of the specimen, so we can move on to trimming the length of the specimen. Now that we have cleaned up our work area a bit and we have trimmed the diameter of our clay specimen, I've put the specimen in the length trimmer, so we can just attach the two pieces together. And then you want to cut off the excess pieces of the clay using the wire saw. Okay, and the next thing you want to do is take the dimensions of your clay specimen. So we'll remove it from the trim device. Just clean up the edges a bit. And to take the measurements, we can use both a ruler and a caliper. So you want to first take the diameter, and we'll take 3 different diameter readings at different locations across the diameter of the clay. And then just rotate it. and then you would take the average and use that in all of your calculations. We can do the same thing for the height. This time we will use I guess we can use a caliper again. You could use a ruler, but to be more precise, we'll use a caliper. Again, using the average of those values for your calculations. Now we are ready to test the clay in our unconfined compression device. Now that our clay specimen is ready for testing, we can place it carefully into the center of this lower platen of the unconfined compression device. And we can raise the platen slightly so that the top of the clay is just slightly near but not touching the upper platen. Okay. Next, you want to zero out your gauges before running the test. So this gauge over here is known as the deform dial. So if you look at your data sheet for this lab, it's the deform dial column. And basically, it is a measure of how far this lower platen is moving up relative to the start of the test, which is why we zero these gauges out. And with each rotation of this crank, the platen moves a set number, which is why you don't have to fill out any numbers on that column of your data sheet. This other dial gauge, which we'll also zero out, is the load dial, also known as the proving ring dial for this device. And it basically gives an indication of how much pressure or load is being applied to the clay surface up at the top here. So now that everything's zeroed out, we are ready to start testing. So the best thing to do is to test with another person, and you want one person to be rotating at a constant speed, and then the other person at the end of each rotation to write down the value that's showing on the load dial, and of course the load dial column on your data sheet. And we want to continue this process until one of three things occurs. So if you look at your lab manual, it lists the three different scenarios for ending the test. So the first one is when the load noted on the proving ring significantly decreases at a certain point. The next is when the load remains constant for 8 or more readings on your data sheet. Or the final condition is when the strain is significantly larger than 20%. So once any one of those three occurs, that's when you can end the test. So now we'll get started. Let me know when you're ready.
Good to go.
Now. 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 Good to go. Okay. So now we've stopped the test because we have gotten to a point when we've had 8 values from our proving ring are all the same number. So we've finished the test. So the final thing to do is to unload, so lower the platen, and to see what our clay looks like after testing. Remove the clay. So you can see, and we can include a close-up version, that there is a failure plane of the clay right here. So we know we've completed the test. And that completes the unconfined compression test.